Well, hello 3C. We're going to carry on with compound interest today, and we're actually going to use a formula. We're going to remind you what compound interest meant from the last spiral, and then we're going to show you how to find the amount of compound interest without having to do that nasty chart that we did before. So we're going to recap that chart to start with. So our topic today is the amount of compound interest, and our goal is I can use the compound interest formula to calculate the amount of investment. So we're going to start by doing it the same way as we did before, just to recap what we did in the last spiral. So we saw in the last lesson, or the last spiral, that compound interest is like investing a new larger amount of money every year. It amounts to interest earned on top of interest, and we're going to look at the compound interest question again, but from a slightly different angle. So here we go. Josh deposits $3,000 in an account that pays 7% compound interest. How much would he have after 5 years? So what that means is that every year Josh keeps 100% of his $3,000, and then the bank pays him 7% more. At the end of each year, he has, now, if you think about it, if he kept 100% of his money and then the bank gave him 7% more, that means that he has 107% of his money. So 107% of the principal he started with. So instead of multiplying by 0.07 and then adding on to the principal, we can do this in one step by multiplying by 1.07. So here's how this is going to work. The principal at the start of the year is $3,000. The amount at the end of the year, we have to do $3,000 times 1.07. And let's get that as a calculation. 3,000 times 1.07 is 3210. So 3210. Now, at the beginning of the next year, they have 3210. And I'm going to write this just a little bit differently, because what we can do is multiply 3210 by 1.07, or we can think of it this way. This 3,000 times 1.07 was actually the 3210, and now I just have to multiply by another 1.07. This should be starting to look a little bit like what we did last time when we were talking about exponential growth questions. Okay, this is an exponential growth question. So we have 3210. I'm just going to multiply that by 1.07. And I have 3434.7. So 3434.7, or 70 cents, since we're talking about dollars and cents. Now, what I want you to notice here, though, is that, I'm just going to use a different color here, we have two of these, so we could have used this as an exponent. So it's 3,000 times 1.07 squared is another way we could have gotten that. And so take a look here, this is just the year, and this is the original amount. So let's try again. Let's get our red crayon back, or red color back. 3434.70 is what we start the year with, but I'm not going to write in 3434.70 here. I'm going to write in what we made before, 3,000 times 1.07 times 1.07. And now we have to multiply again. Since this is year 3, we're going to multiply by 1.07 again. And again, up here I have what we had before, 3434.70, and I times that by 1.07, and I get 3675.13. 3675.13. Now I'm just going to show you that, and here we go, we'll take the blue again, that this could have been, oops, that's really thick. I'm not going to fit it all in there. Okay, we could have gotten the same number if I did 3,000 times 1.07, and it's year 3, so I have multiplied by 1.073 times, so I need an exponent of 3. Let's actually plug this in and you'll see that we get 3675.13. So let's pull this back up, and I'm going to type in that this formula, 3,000 bracket 1.07 bracket to the exponent, that's this button here, 3. You see we get exactly the same numbers we had before. This makes it a whole lot easier. We no longer have to keep doing this pattern that we did back in Spiral 2. Now I know what to do down here. This is 3,000 is what we started with, and I'm multiplying by 1.07, and since this is year 5, I've done it 5 times. So now we're just going to plug that in rather than going through all this process. I don't even have to do year 4, okay, unless I really wanted year 4. And we go back up to here. Let's type it in again. 3,000 bracket 1.07 to the exponent 5. And my answer is 4207.66. So 4207.66. So now we're going to summarize what I just did here for you in a formula. So what we really did was multiply 3,000 by 1.075 times. So a shorter way to write that is what we did before, 3,000 times 1.075 times, where this here is the principal, this here is the number of interest payments, and this here was 1 plus the interest rate. So here's how we're going to summarize it into the formula down here. It's A, which is the amount after n compound periods, so this is the number of times we get interest. This is the rate, so we have to do 1 plus I, and the principal is the initial amount invested. So it's all summarized for you right there. And we're just going to do one question with it, and then I'll let you get to your homework. So if we're going to do this, anytime you use that formula, I want to see it written down. So A equals P, 1 plus I to the n. And in this case, here's our P. This is our I, except that we don't use it as 3.5. We got to change it to 0.035. And this is our n. So here we're going to plug it in. 2,500 bracket 1 plus 0.035 to the exponent 5. Now, most calculators can handle this all at once if you use the brackets. And since you're writing the brackets, you might as well use the brackets as well. So put that right down here. And this is how we're going to type it in. 2,500 bracket 1 plus 0.035 end bracket to the exponent 5. Hit equals. 2,969.22. 2,969.22. Now, this is the total amount. If we want to know how much interest we earned, we have to know that 2,500 of this is actually our money to start with. Interest is only the stuff that the bank gives you, so we have to subtract off what we started with to figure out what the bank gave us. So the formula for finding interest, once you've found the amount, is going to be the final amount subtract the principal. So 2969.22 subtract 2,500 is going to be $469.22. And that's really all there is to it.